Think of quantitative problem solving as a reliable recipe for turning a fuzzy real-world question into a number you can trust. Follow a repeatable process, lean on useful heuristics, and always run quick sanity checks to catch mistakes early. Start by making the question precise. In one sentence, restate what you're being asked and what counts as an acceptable answer. Then build a model. Pick the assumptions and simplifications that keep the problem tractable. Translate the words into variables and relationships, and write down the equations. Choose the tools that fit the problem: algebra, calculus, probability, statistics, dimensional checks, or a quick numerical script, and then solve, keeping units and significant figures in mind. Don't stop at the algebra. Check the result by testing limiting cases, comparing orders of magnitude with known benchmarks, and explaining what the number actually means. If something smells off, go back and refine your assumptions or model. There are a few heuristics that pay huge dividends. Strip away negligible effects first and build complexity only as needed. Use dimensional analysis to catch algebra slips and to guide how variables can combine. Test extreme limits, variables to 0 or infinity, to see if the model behaves sensibly. Think in scales and orders of magnitude. Often the exponent or the scale matters more than precise constants. When exact answers are hard, bracket the solution with upper and lower bounds. Exploit symmetry or conservation laws to reduce variables. And when the algebra is messy, switch to numerical work or use Taylor expansions for small parameters. To make this concrete, try a classic Fermi estimate. How many piano tuners are needed in a city of 3 million? Restate the goal, then make reasonable assumptions. Roughly 1 household per 3 people gives about 1 million households. Suppose 1 in 20 households has a piano, so about 50,000 pianos. Assume each piano needs 1 tuning a year, and that a tuner can do about 4 tunings a day, 5 days a week for 50 weeks, which is about 1,000 tunings per year. Dividing 50,000 pianos by 1,000 tunings per tuner gives about 50 tuners. That's the kind of order of magnitude answer you want. Simple assumptions, a short chain of arithmetic, and a quick plausibility check, 1 piano per 60 people, to confirm it sits in the right ballpark. For an optimization example, consider maximizing the area of a rectangle with fixed perimeter. Translate the perimeter constraint into one side expressed in terms of the other. Write area as a single variable function, differentiate, and set the derivative to 0. You find both sides equal. A square maximizes the area. A second derivative check confirms it's a maximum. That pattern, reduce variables, set derivatives to 0, and verify concavity or boundary behavior, works for many constrained optimization problems. Watch out for common pitfalls: losing track of units, overfitting models with too many parameters when data are sparse, treating assumptions as facts instead of hypotheses, and simple arithmetic slips. Simple plausibility checks, units, orders of magnitude, and comparisons to familiar benchmarks. Catch most errors quickly. If you want to get better, practice with many Fermi-style questions to build intuition, work optimization problems under different constraints, drill conditional probability puzzles, and rehearse dimensional analysis checks. Approach every new quantitative problem by stating clear assumptions, starting with the simplest model that could work and continuously sanity checking as you add complexity. That habit keeps solutions tractable, interpretable, and robust.